Okay, so you're building an API. You need to handle users, and you're staring down the barrel of three big options: Basic Auth, bearer tokens, and JWTs. It's like the classic developer dilemma, right?
So, which one is it going to be? Basic, bearer, or JWT?
Let's really get into this, because picking the wrong one isn't just a minor oops, it can be a full-blown security nightmare. So how on earth do you choose the right one for your project? Well, that's exactly what we're going to unpack right here, right now.
But first, to really get it, we need to understand the core problem. Like, why do we even need this stuff in the first place?
The entire challenge, honestly, boils down to one simple fact. HTTP is stateless. What that means is the server has absolutely zero memory of what just happened. It's like it has total amnesia. Every single time you talk to it, it's a clean slate. Think about it like a drive-thru, you know? You pull up, you place your order, you get your food, and then that little window slides shut. The second the next car pulls up, poof. As far as the server is concerned, you never even existed. That's great for speed, but it means you have to prove who you are over and over and over again. And that's where these authentication methods come into play. So let's start at the beginning with the simplest one of them all, Basic Auth. The process here is, well, it's incredibly simple. You just take your username and password, you stick a colon right in between them, and then you encode that whole thing in base64. Then you just slap that into an authorization header and you send it with every single request.
Now hang on, here's the part that trips up so many developers, and it is absolutely critical from a security standpoint. Base64 is not encryption, not even close.
Just think of it like gift wrap. Yeah, it makes the package look a little different, but literally anyone can tear it open in about 2 seconds. Its only job is to make sure the credentials play nice with HTTP headers, which can be kind of picky about the characters they accept. It is all about compatibility, not security. Sending this over plain HTTP is basically like screaming your password out in a crowded room.
Okay, so obviously, we need something better for most real-world APIs, and that brings us to our next method, bearer tokens, the gatekeeper.
You know, a common point of confusion is the word bearer itself. Let's clear that up. Think of bearer as the scheme. It's like the envelope. It just tells the server how to handle what's inside. The token itself, that's the badge. That's the important part that tells the server who you are. So the client shows its credentials once, gets this badge back, and then just flashes that badge for every request after that.
But there's always a but, right? Here's the big trade-off. Because this token is just a random string of characters, we call it an opaque token, the server has no idea what it means on its own. So it has to look it up in a database on every single request just to figure out who it belongs to and if it's still valid. Now, for a high-traffic app, that can become a serious performance bottleneck.
So that leads to an interesting thought. What if the token could carry its own information, and get rid of that database lookup? Well, that's the exact problem that our next method solves, JWTs, the self-contained key.
A JSON Web Token, or JWT for short, is made up of 3 parts, and they're all separated by dots. First up, you've got the header, which just says what algorithm is being used. Then comes the payload, and this is where your data lives. Things like a user ID or roles. And finally, the most important piece for security, the signature.
And listen, if you remember one thing about JWTs, make it this. The payload part is just base 60 encoded. Remember our gift wrap analogy? That means it is readable by anyone. You can literally copy a JWT from your browser, paste it into a decoder online, and see everything inside. The real security comes from the signature. It's cryptographically signed, which makes the token tamper-proof. It proves the data hasn't been messed with, but it does not make the data private.
Which brings us to the absolute golden rule of JWTs. Never, and I mean never, put sensitive data in a JWT payload. No passwords, no credit card numbers, nothing you wouldn't be comfortable shouting from a rooftop.
So why would we go through all this trouble? Performance, plain and simple. Verifying a mathematical signature is something like 5 to 10 times faster than hitting a database. This lets your services scale like crazy without needing some complicated shared session database. It is a huge win.
Now you've basically got 2 main ways to sign these tokens. There's HS256, which is symmetric. Think of it like a house key. The same key locks and unlocks it. That's great for simple apps, monoliths, where one service is doing everything. Then you've got RS256, which is asymmetric. This is more like a mailbox. There's a private key to sign the token, put mail in,
but a public key can be shared with everyone to verify it, to check for mail. This is absolutely perfect for microservices, where one auth service signs tokens and a bunch of other services just need to check if they're legit.
Okay, we've covered the how. Now for the really important part. Choosing the right tool for the job and, actually securing your API.
Let's just make this super simple. If you're building an internal tool or just working on your local machine, Basic Auth over HTTPS is probably fine. For a straightforward public API, especially a monolith, opaque bearer tokens are a fantastic choice. They're secure, they're simple, and they're easy to revoke. But if you're building for scale with microservices, JWTs were literally designed for that exact problem.
And look, no matter which method you pick, these security rules are not suggestions. They are absolutely non-negotiable. 1. Always, always, always use HTTPS. 2. Store your tokens securely, ideally in HTTP-only cookies to protect against XSS attacks. 3. Keep your access tokens short-lived. 4. Use battle-tested crypto libraries. Do not try to roll your own. And 5. Whitelist the specific algorithms you accept. It's a simple step that prevents a whole class of attacks.
All right, let's bring this all home. What's the final takeaway here?
So let's just do a quick recap of the trade-offs. Basic Auth, super simple, but it's sending your credentials over and over again. Opaque bearer tokens, they're secure and super easy to revoke, but they come with that performance hit of a database lookup every single time. And JWTs, they're fast, they're stateless, they're built for scale, but trying to revoke one instantly? Yeah, that gets complicated. It's all about trade-offs.
So now we've figured out how your server can know who you are, authentication. But what about that next level? When you see a sign in with Google button, how does that work? Well, that's a whole different ballgame called authorization, and it's where things get really interesting. We'll break that down next time.